What if the deepest part of the ocean is hiding something we've been looking for all along? You know that feeling when you are in your house late at night, and you hear a sound from somewhere you cannot quite place. Maybe it is the basement, or behind a closed door, and part of you wants to investigate while another part says, maybe not right now. That's sort of how we are with the ocean. We live on this planet. We've mapped distant galaxies. We've sent robots to Mars. But there's this massive part of our own home that we barely looked at. And it is not like it is hidden on the other side of the world. It is right here, covering more than 2/3 of our planet. If you are the kind of person who wonders about these things, who looks at the world and thinks there's got to be more to the story, then maybe you could help our sleepy little signal find its way to other people who might be wondering about this too. There's something nice about knowing you are not the only one staring at the ocean and thinking, what's really down there? I wonder what the weather's like where you are right now. Are you somewhere warm? Somewhere cold? Are you listening to this while you are doing something else? Or are you just here with me for a bit? Wherever you are, I am glad you are here. What we are about to explore together isn't going to give you all the answers. Honestly, it is going to give you more questions, and maybe that's exactly what makes it worth thinking about. We are going to take a gentle journey through one of the most fascinating ideas I have come across, the possibility that Earth's deepest places might be keeping secrets about who we used to be. So get comfortable. Maybe grab something warm to drink. Let's begin. The Mariana Trench is the deepest part of our ocean, and when I say deep, I mean really deep. If you took Mount Everest, the tallest mountain on Earth, and dropped it into the Mariana Trench, the peak wouldn't even break the surface. It would be covered by over a mile of water. We are talking about nearly 36.0 feet down to a place called the Challenger Deep. Now here's what gets me. We've spent more time and resources exploring the surface of the moon than we have exploring our own ocean floor. Think about that for a second. We've got detailed maps of Mars. We know what the far side of the moon looks like. But down there, in the deepest parts of our own ocean, we've barely scratched the surface. Less than 20% of the ocean floor has been mapped in any detail at all. The pressure down there is almost impossible to imagine. It is not just that it is heavy, it is crushing. We are talking about pressures that would collapse a submarine like you'd crush a soda can in your hand. 8 tons per square inch. If you or I tried to go down there without protection, we wouldn't last a fraction of a second. Our bodies would just cease to be. Only 3 people have ever made it to the very bottom of the Challenger Deep. 3 people. In all of human history. Think about how many people have climbed Everest. Thousands. How many people have been to space? More than 600. But the deepest part of our own ocean? 3. One of them was James Cameron, the filmmaker, back in 2012. He went down there alone in a specially designed submersible, and you know what he found. Darkness. Crushing pressure. Isolation. And life. Strange, alien-looking life that somehow thrives down there. But what struck him most, what he talked about afterwards, was the emptiness. The vast, quiet emptiness of it all. But here's the thing about emptiness. It is only empty until you find something. And we haven't really looked yet. Not properly. The technology to explore these depths, safely and thoroughly, is only just starting to exist. For most of human history, the deep ocean has been completely inaccessible to us. It has been locked away, like that basement I mentioned earlier. And that's what makes it the perfect place for secrets to hide. No light reaches down there. I do not mean it is dim, I mean zero light. Complete, absolute darkness. The kind of darkness that's never seen the sun, not in millions of years. If something wanted to remain hidden, if something wanted to be left alone, the deep ocean would be the ideal place. No satellites can see through miles of water. No aircraft can spot anything on the seafloor. Even our most sophisticated sonar cannot penetrate deep into the sediment that covers the ocean floor. It is the last place on Earth where you could genuinely hide something massive. And there's something about that idea, something about unexplored spaces, that captures our imagination, isn't there? We are drawn to it. We are curious creatures by nature. We see a closed door, and we want to know what's behind it. We hear about an unmapped region, and we want to explore it. It is built into us. Part of it is practical, of course. We want to understand our planet. We want to know what resources are down there, what life exists there, how the ocean affects our climate and our weather. There are legitimate scientific reasons to explore. But there's another part, a deeper part, that's less about science and more about wonder. We want to know if we are alone. We want to know if there are mysteries still left to solve. We want to believe that the universe, or at least our little corner of it, still has the capacity to surprise us. And maybe, just maybe, we want to believe that humanity isn't the first time something like this has happened. That we are not the only ones who've ever built something, wondered about the stars, tried to make sense of it all. What if we are not the first? What if there were others before us, civilizations that rose and fell before we ever arrived? And what if some of them, when things went wrong, when their world changed in ways they couldn't control, found a way to survive in the one place no one would think to look? It sounds like science fiction, doesn't it? Like something out of a movie or a novel. And maybe it is. Maybe it is just a story we tell ourselves because we like mysteries, because we like the idea that there's more out there than meets the eye. But here's what makes it interesting. We know civilizations have disappeared. We've got historical records of advanced societies that just vanished. Entire cities abandoned. Technologies lost. Languages forgotten. It has happened before, multiple times, and we still do not fully understand why or how. We also know that Earth has been through some serious changes. Dramatic, sudden climate shifts that happened faster than anyone living through them could have predicted. Ice ages that arrived in years, not millennia. Sea levels that rose and fell by hundreds of feet, drowning coastlines where people live. And we know, this is the part that gets me, we know that life exists in the deep ocean in ways we never thought possible. Life that doesn't need the sun. Entire ecosystems that run on chemistry instead of photosynthesis. If life can adapt to that, if life can find a way to thrive in conditions that seem utterly hostile to everything we know about biology, well, what else is possible? I am not saying there's definitely a lost civilization hiding in the Mariana Trench. That would be a pretty big claim to make without evidence. But what I am saying is this, we do not know there isn't. We haven't looked. We cannot look, not really, not yet. And that gap between what we know and what we do not know, that's where all the interesting questions live. So, that's where we are going together. We are going to explore that gap. We are going to look at what we know about the ocean, about lost civilizations, about the dramatic changes Earth has been through. We are going to ask questions that might not have answers yet. And we are going to wonder, together, about what might be waiting down there in the dark. Because wondering, really wondering, staying curious, staying open to possibilities, that's what keeps us human. That's what makes us who we are. Let's talk about one of the strangest facts about our planet. We know more about the surface of Mars than we do about the bottom of our own ocean. Think about that for a second. We've got high-resolution maps of craters on the moon. We've landed rovers on Mars and watched them drive around for years. But right here on Earth, there's a place so deep, so unknown, that only 3 people in human history have ever been there. It is called the Challenger Deep, and it sits at the bottom of the Mariana Trench in the western Pacific Ocean. Here is how deep we are talking. If you took Mount Everest the tallest mountain on Earth, and dropped it into the Challenger Deep, the peak wouldn't even break the surface. There'd still be over a mile of water above it. We are talking nearly 36.0 feet down, or about 7 miles beneath the waves. And the pressure down there is crushing. Literally. At that depth, the weight of all that water above you creates a pressure of about 16.0 pounds per square inch. That's more than 1,000 times the pressure you feel standing at sea level. It would crush a regular submarine like you'd crush a soda can in your hand. Even specialized vessels built specifically for the deep ocean can only handle so much before the hull starts to crack. Only 3 manned descents have ever reached the bottom of the Challenger Deep. The first was in 1960, when 2 explorers squeezed into a tiny steel sphere and dropped into the darkness. Then nothing. Nobody went back for over 50 years. Not until 2012, when filmmaker James Cameron made a solo dive in a specially designed submersible. And what did he find down there? Well, that's the interesting part. He found life, strange, alien-looking creatures that somehow thrive in conditions that would kill us instantly. He found sediment that's been settling there for millions of years. But he also found something else: vastness, emptiness. A landscape so enormous and so unexplored that his lights could only illuminate a tiny bubble of visibility in the endless dark. Cameron spent just a few hours down there. In all of human history, we spent less than a day actually exploring the deepest part of our own planet. Think about that. Less than 24 hours of human presence in a place that covers more area than the entire continental United States. It is not just the Challenger Deep, either. The deep ocean, anything below about 650 feet, makes up roughly 95% of Earth's habitable space. And we've mapped maybe 20% of it. The rest? It is what scientists call unexplored, which is a polite way of saying we genuinely have no idea what's down there. We've got better maps of Venus than we do of most of our seafloor. Part of the problem is how hard it is to see down there. In space, you can send a telescope. You can bounce radio waves off distant objects. But in the ocean, light doesn't travel far. Even in the clearest water, sunlight vanishes completely by about 300 feet down. Below that, it is not just dark, it is a darkness unlike anything you've ever experienced on land. Total. Absolute. The kind of darkness where your eyes do not adjust, because there's literally nothing to see. And sound. Sonar can map the ocean floor, but it is slow, expensive, and it can only tell you the general shape of what's down there. It cannot distinguish between a natural rock formation and something that might have been built. It cannot see through layers of sediment that have been piling up for thousands of years. So when you put it all together, the crushing pressure, the total darkness, the sheer size of it, and how little we've actually explored, the deep ocean becomes the perfect place for secrets. Not because something's necessarily hiding down there, but because if something was hiding, we genuinely might not know. It is like having a basement in your house that you've never been able to access. You know it is there. You can hear pipes running through it sometimes. But the door's locked, you've lost the key, and you've never quite gotten around to breaking it open. That's our relationship with the deep ocean. And here's what makes it even more fascinating. We didn't always ignore it like this. There was a time when people were genuinely obsessed with what might be lurking in the depths. In the 1800s, scientists believed in the azoic theory, the idea that nothing could possibly live below a certain depth. They thought the deep ocean was completely lifeless, a dead zone where the pressure and darkness made life impossible. Then we started pulling up nets full of strange creatures from depths we'd thought were barren. That theory fell apart pretty quickly. But even now, with better technology, every deep-sea expedition finds something unexpected. New species, weird geological formations, Phenomena that do not quite make sense. In 1997, underwater microphones picked up an ultra-low frequency sound in the Pacific that was loud enough to be heard from sensors thousands of miles apart. They called it the bloop. Nobody knew what made it. The sound was consistent with a living creature, but it would have had to be massive, much larger than a blue whale. Eventually, scientists figured out it was probably an ice quake, ice cracking and breaking off glaciers. Probably. But for years, nobody knew. And that's the thing about the ocean. It can still surprise us. It can still produce mysteries that take decades to solve, if we ever solve them at all. There's something deeply compelling about that, isn't there? In an age where we can pull up satellite images of any street corner on Earth, where we've got rovers exploring Mars, the idea that there's still a frontier right here at home, a place we genuinely haven't looked yet, it scratches some fundamental human itch. It is the same feeling that drove explorers to cross oceans in wooden ships, not knowing what they'd find. The same curiosity that made people wonder what was beyond the next mountain range, the next horizon. We like to think we've got it all figured out, that the age of exploration is over. But we haven't even seen most of our own planet. And here's the really wild part. What if we've been looking in the wrong places this whole time? What if the answers to some of our biggest questions about human history aren't buried in some desert or jungle waiting to be excavated? What if they sank? Because the ocean hasn't always been where it is now. Sea levels have risen and fallen dramatically throughout human history. Coastlines that existed 10,000 years ago are now hundreds of feet underwater. And people lived on those coastlines. They built there. They thrived there. Then the water rose, and all of it vanished beneath the waves. So when we talk about the deep ocean being Earth's final frontier, we are not just talking about exploring for the sake of curiosity. We are talking about the possibility, however remote, that somewhere down there, beneath the sediment and the darkness and the crushing pressure, there might be answers we didn't even know we were looking for. The Mariana Trench keeps its secrets well. But we've only just started asking the right question. And yet, if secrets could hide anywhere, maybe the ocean isn't the only place we should be looking. Maybe we should also be looking backward, into the spaces where entire civilizations simply stopped existing. Because here's the thing that keeps archaeologists awake at night. Throughout human history, advanced societies have vanished with almost no warning. Not gradually declining over centuries, but disappearing so abruptly, it is like someone flipped a switch. Take the Minoans. Around 1450 BCE, they were thriving on Crete, building multi-story palaces with running water, creating art that still takes your breath away, trading across the Mediterranean. Then suddenly, nothing. Palaces abandoned mid-activity. Storage rooms full of grain. Tools left where they fell. It is like everyone just walked away from their lives and never came back. The Maya did something similar. We are talking about a civilization that built massive stone cities in the jungle, developed complex mathematics, tracked the movements of Venus with incredible precision. Then sometime around 900 CE, they started leaving. Not all at once, but city by city. These incredible urban centers were reclaimed by the forest. Some archaeologists have found evidence suggesting meals were left half-eaten. The people didn't just decline, they departed. Or, consider the Indus Valley civilization. Between 3300–1300 BCE, they built sophisticated cities with grid-pattern streets and advanced drainage systems. We are talking about urban planning that rivals anything from the ancient world. And then, they are just gone. No signs of invasion. No evidence of warfare. The cities weren't destroyed, they were abandoned. The people melted back into smaller settlements, and one of history's great civilizations faded into silence. But the one that really makes you wonder is Göbekli Tepe in Turkey. Here's a site that predates Stonehenge by 60 years, massive stone pillars arranged in circles, carved with intricate reliefs of animals, clearly the product of organized, skilled labor. This place was built 11,000 years ago, which means it is older than agriculture, older than cities, older than everything we thought we knew about when humans could coordinate large-scale construction projects. And here's the kicker: the people who built it deliberately buried it. They didn't abandon it to the elements. They carefully filled it in with dirt and rubble, preserving it, hiding it, making it disappear from view. Why would you invest generations of effort into building something magnificent, only to bury it yourself? That's the pattern that keeps repeating. Advanced societies do not just fail, they erase themselves, or leave so quickly they do not have time to write down what happened. It is like finding a diary that has entries every single day for years, and then it just stops mid-sentence, with no explanation. The mystery isn't just what happened, it is why nobody documented the ending. Now, the official explanations vary. For the Minoans, most scholars point to the volcanic eruption on Thera, modern-day Santorini, which would have triggered tsunamis and devastated trade routes. For the Maya, it is usually drought combined with overpopulation and warfare. For the Indus Valley, maybe climate change shifted the monsoons, drying up rivers. For Göbekli Tepe, we honestly have no idea. But here's what makes these stories resonate with people today. They all suggest that history isn't as stable as we like to think. We are taught that civilization is this steady upward march, from caves to cities to skyscrapers. But what if it is not? What if it is more cyclical? What if societies rise, flourish, and then something happens? Something environmental, something catastrophic, something we do not fully understand, and they have to start over. That's where reset theories come from. Not from conspiracy thinking, but from a very real observation. We have clear evidence of advanced societies that just stopped. And the gaps in our knowledge are massive. We've got written history going back maybe 50 years, but anatomically modern humans have been around for 200 years. That's 195 years, where we are basically guessing what happened based on scattered artifacts and bones. Think about what could disappear in that time frame. Wood rots. Fabric disintegrates. Even stone structures crumble under enough weather and vegetation. If a civilization existed 50 years ago and then collapsed, what would we find today? Maybe nothing. Maybe scattered stones that we'd assume were natural. Maybe myths and stories passed down so many generations that we dismiss them as fantasy. And that's the uncomfortable thought. What if we are not the first time humans got this far? What if there were other societies, other attempts at civilization, that rose and fell in those 195 years before writing? We wouldn't necessarily know. The evidence would be gone, swallowed by time, by sea level changes, by geological processes we can barely comprehend. This isn't about believing every fringe theory. It is about acknowledging how much we genuinely do not know. Every few years, archaeologists push back the dates on something. When humans first made art, when we first built permanent structures, when we first crossed oceans. We keep finding that our ancestors were more capable, more sophisticated, more adventurous than we thought. So when civilizations vanish without explanation, when they leave behind mysteries instead of answers, it plants a question that's hard to ignore. Where did they go? Did they die out? Did they scatter? Did they adapt to new circumstances in ways we haven't considered? Because if a society faced an existential threat, a climate shift happening too fast to outrun, a disaster that made the surface world unlivable, what would they do? Where could they go that would offer protection from whatever was destroying their world above? The ocean isn't just deep. It is constant. It is insulated from surface catastrophes. It is the one place on Earth where conditions stay relatively stable, even when everything above is in chaos. And we've already established something remarkable. We know almost nothing about what's down there. So if we are wondering whether anyone could have survived a catastrophic event by retreating to the ocean floor, we first need to understand what kind of events we are talking about. And here's where the science gets genuinely unsettling, because Earth's climate doesn't change gradually like we tend to imagine. Sometimes it flips like a switch. Let's talk about the Younger Dryas. Around 800 years ago, the planet was warming up nicely after the last ice age. Things were looking good. Then suddenly, and I mean suddenly, Earth plunged back into ice age conditions. We are talking about a temperature drop of around 15 degrees Fahrenheit happening not over centuries, but in less than a decade. In some regions, it might have happened even faster than that. How do we know this? Ice cores from Greenland. Scientists drill down through layers of ancient ice, and each layer tells a story about the year it formed. Temperature, atmospheric conditions, even what the air was like. And when they examined these cores, they found something shocking. The climate signature changes dramatically within the span of just a few annual layers. It is like reading a diary where someone writes "beautiful spring day," and then the very next entry says everything is frozen, and we are running out of food. Now, you might be thinking, okay, but what caused it? That's the fascinating part. We are still not entirely sure. There are three main theories, and they are all pretty dramatic. Some scientists think it was an asteroid or comet impact. Others point to massive volcanic eruptions that filled the atmosphere with ash. And then, there's the collapsing ice sheet theory, the idea that huge chunks of the North American ice sheet broke off and disrupted ocean currents, particularly the Gulf Stream, which acts like Earth's central heating system. Whichever it was, the effect was catastrophic. And here's what really matters for our story. If you were a coastal civilization at that time, you didn't just deal with the cold. Sea levels had been rising for thousands of years as the ice age ended. We are talking about 400 feet of sea level rise since the peak of the last glaciation. That's a 40-story building worth of water covering what used to be dry land. Think about that for a moment. Entire continental shelves that were once grasslands, forests, and river valleys, home to who knows how many people, just gone. Drowned. And it didn't happen all at once, but it happened fast enough that within a handful of generations, the world map looked completely different. Now, let's go back even further. About 74 years ago, Mount Tuba in Indonesia erupted. This wasn't just any volcanic eruption. It was a supervolcano, one of the largest eruptions in the last 2 million years. It ejected so much ash and sulfur into the atmosphere that it likely triggered a volcanic winter lasting years. Some estimates suggest global temperatures dropped by up to 20 degrees Fahrenheit. And here's where it gets really interesting. We can see the aftermath of Tuba in our own DNA. Human genetic diversity shows a dramatic bottleneck right around this time, meaning the global human population crashed hard. Some estimates suggest we might have dropped to as few as 10 individuals worldwide. We nearly went extinct. But some people survived. They had to adapt, had to find ways to endure conditions that killed almost everyone else. And that's the pattern we keep seeing throughout prehistory. Earth throws these reset events at life, and life finds a way to continue, often in the most unexpected places. So here's the question that ties all of this together. If you were alive during one of these catastrophic climate shifts, where would you go? The surface is freezing, volcanic ash is blocking out the sun, sea levels are dramatically changing, and ecosystems are collapsing. You need somewhere stable. Somewhere that chaos cannot reach. The deep ocean starts looking pretty appealing, doesn't it? Because here's something remarkable about the deep sea. Its temperature barely changes. Surface oceans can swing wildly with the seasons and the climate. But below a certain depth, it is consistently cold and stable, year after year, century after century, ice age or no ice age. If you had the technology, and that's a big if we'll explore later, the deep ocean might actually be the safest place during a surface catastrophe. The pressure would be your main enemy, but it is constant and predictable. The temperature wouldn't kill you because it doesn't change. And food. Well, those hydrothermal vents we'll talk about later do not care what's happening on the surface. They keep pumping out energy regardless. Now, I am not saying this definitely happened. But when you look at the evidence, the speed of these climate changes, the proof that they nearly wiped us out before, the fact that they forced radical adaptations in the survivors, you start to understand why the idea resonates. Our ancestors faced genuine apocalypse-level events multiple times. And each time, someone, somewhere, figured out how to survive. The climate has always been our greatest challenge, and it has always been unpredictable in ways that defy our intuition. We imagine change happening slowly, giving us time to adjust. But the geological record tells a different story. It tells us that Earth's climate can shift faster than a civilization can relocate, faster than crops can adapt, faster than infrastructure can be rebuilt for new conditions. And that creates a very specific kind of evolutionary pressure, not just to adapt, but to adapt radically. To abandon the old ways entirely if necessary. To go to places that seem impossible, if those impossible places offer survival. The Younger Dryas eventually ended. Temperatures warmed again, roughly 700 years ago, marking the beginning of our current geological epoch, the Holocene. And it is in this relatively stable period that civilization as we know it emerged. Agriculture, cities, writing, all of it. We built everything we have in this narrow window of climatic stability. But that window has opened and closed before. And the closing has never been gentle. But that window has opened and closed before. And the closing has never been gentle. And here's the thing, people remembered. Not in the way we remember facts from a textbook, but in the way your body remembers falling off a bike. Deep memory. The kind that gets woven into stories, passed around fires, embedded into the foundation of how a culture sees the world. Which brings us to one of the most fascinating patterns in human history, the legends. The myths. The stories about cities and civilizations that didn't just fall, they sank. And these stories appear everywhere. Cultures that never contacted each other, separated by thousands of miles of ocean, telling remarkably similar tales about the same thing. Advanced societies swallowed by water. Let's start with the famous one. Plato's Atlantis. Now, most people think of Atlantis as ancient fantasy fiction, right? A cautionary tale Plato made up to teach philosophy students about hubris. And maybe that's all it was. But here's what makes it interesting. Plato didn't write it like fiction. He wrote it like a historical account that had been passed down through generations. He included measurements, the city's dimensions, the width of its canals. He described its government structure, its military capabilities, its geography. He even specified when it supposedly existed, 9,000 years before his own time. That's not how you write a parable. That's how you write down something someone told you was real. And Plato wasn't alone. Halfway across the world, Tamil literature speaks of Kumari Kandam, massive landmass that once stretched south from India before being consumed by the ocean in stages. The texts describe it as a sophisticated civilization with academies, poets, and kingdoms. They even name the successive floods that took it piece by piece. In Japan, there are legends of Raijijijo, the underwater dragon palace, where a fisherman once visited and discovered that time moved differently beneath the waves. A few days underwater, and decades had passed on the surface. It is mythology, sure. But it is mythology about underwater civilizations that exist in parallel to our own, hidden, in the deep. Now, here's where it gets really interesting. Some of these stories actually match the geological record. Indigenous Australians have oral histories about when you could walk to Tasmania, about the flooding of coastal areas, about islands that used to be mountains. For a long time, these were dismissed as legends. Then scientists started dating the actual land bridge between Australia and Tasmania, and guess what? The stories were right. The timeline matched. Sea levels rose, the land bridge flooded, and the people who witnessed it told their children, who kept the story alive for 10,000 years. The same thing happened with Native American tribes in the Pacific Northwest. They had detailed flood myths about walls of water, catastrophic deluges that reshaped the landscape. Geologists found evidence of massive floods at the end of the last ice age, glacial lake outbursts that would have dwarfed anything in recorded history. The oral traditions preserve the memory of real events that happened over 11,000 years ago. So you start to wonder, if some of these flood myths are based on actual catastrophes, what about the others? Why do cultures separated by entire oceans tell the same story about advanced people who fled beneath the waves? The Epic of Gilgamesh, one of humanity's oldest written texts, describes a great flood and a man who survived by building a vessel. The Norse had their own flood myths. Mesopotamian cultures, Polynesian islanders, civilizations in Central America, over 200 cultures worldwide, have flood narratives embedded in their foundational stories. That's not coincidence. That's pattern. Now, does that mean Atlantis was real? Does it mean there's a hidden Tamil continent waiting to be found? Not necessarily. But it means something happened. Something big enough and traumatic enough that it became part of our species' collective memory. And here's the thing about myths. They are not photographs. They are more like impressions. They are memories filtered through generations of retelling, shaped by culture, by language, by the need to make sense of something too big to fully comprehend. Details shift. Names change. But the core, the emotional truth, remains. Think about it like this. These myths are echoes. And when you hear the same echo coming from caves that do not connect, you start wondering if there was one very loud sound that traveled everywhere. The details in these legends are strikingly specific. Plato's Atlantis had a sophisticated irrigation system. Kumari Kandam had organized governments. The stories do not describe primitive tribes. They described structured societies with technology, with culture, with the kind of complexity that takes centuries to build. And then they describe that complexity vanishing beneath the ocean. Here's what we know for certain. Sea levels have risen over 400 feet since the last ice age. That's not a myth. That's measurable fact. Entire coastlines that were once inhabited are now underwater. And the people living on those coastlines? They would have been the most advanced of their time. Coastal populations always are. Access to the ocean means trade, diverse food sources, the development of boats and navigation. Maritime cultures innovate. So when the water came, and it did come, we have the evidence. Those coastal populations would have had two choices: retreat inland or adapt to the water. Most retreated. We can trace the archaeological record of people moving to higher ground. But what if some didn't? What if some looked at the rising waters and thought, we can work with this? We know the ocean. We understand it better than the people inland. What if we go deeper instead of higher? It sounds impossible. But humans have always chosen the impossible over giving up what they've built. And so, the stories were born. Or remembered. Or both. The myths serve another purpose too. They keep us humble. They remind us that we are not the first to build something impressive. That the people who came before us weren't primitive. That history isn't a straight line of progress from ignorance to enlightenment. It is messier than that. It is a story of cycles, of rising and falling, of building and losing and building again. And maybe, just maybe, some of those who fell found a way to keep building in places we haven't thought to look. Because if there's one thing these legends all agree on, it is this: the ocean doesn't just take. Sometimes it keeps. So if the ocean keeps these stories, these memories, what exactly has it been keeping? Let's talk about what we've actually found down there. And I want to be clear, when we say found, we are not talking about confirmed ancient cities with welcome signs. We are talking about structures, formations, anomalies that make archaeologists raise their eyebrows, argue with each other at conferences, and occasionally lose sleep wondering if they are looking at something incredible or just really interesting rock. Start with the Bimini Road in the Bahamas. Discovered in 1968, it is exactly what it sounds like: a formation of rectangular limestone blocks, arranged in a neat line stretching for half a mile along the ocean floor. They are geometric. They fit together. They look exactly like a road someone laid down. Some researchers look at it and see clear evidence of human construction. Others look at the same stones and see a natural formation called beach rock, limestone that forms in neat, linear patterns when certain conditions align. Here's the fascinating part: both sides have good arguments. The "it is natural" camp can point to chemical analysis and similar formations elsewhere. The "it is man-made" camp can point to the precise angles and the fact that some blocks appear to have tool marks. They've been arguing about it for over 50 years, and neither side has definitively won. That's how murky underwater archaeology gets. Then there's the Yonaguni Monument off the coast of Japan. This one's even more dramatic. Imagine massive stone terraces, steps, platforms, and right angles carved into rock formations 80 feet below the surface. It looks like a sunken temple complex. It looks like something humans deliberately shaped. Marine geologist Masaki Kimura has spent decades arguing it is a 10,000-year-old structure. Meanwhile, other geologists look at the surrounding bedrock and say it is a natural formation, sandstone that fractures along straight lines when it erodes. Who's right? We honestly do not know. What we do know is that the site is real, it is there, and it is strange enough that people cannot agree on what they are seeing. In 2011, Swedish treasure hunters scanning the Baltic Sea floor found something that broke the internet: a 200-foot circular formation sitting 300 feet down. The sonar image showed what looked like a massive disk with geometric features. Wild theories exploded overnight: lost city, alien spacecraft, secret Nazi technology. Reality turned out to be more mundane but still interesting. It is probably a glacial deposit, rocks dragged and dropped by ancient ice sheets. But here's the thing: probably is doing a lot of work in that sentence. The formation is real. The explanations are best guesses based on limited data. Now we get to Dwarka, off the coast of India, and this is where things get legitimately exciting from an archaeological perspective. Underwater explorations near the legendary city mentioned in Hindu texts have revealed stone structures, walls, and artifacts. Some of these formations have been dated to roughly 90 years ago. Unlike the previous examples, archaeologists generally agree that something human-made is down there. The debate isn't whether it exists, but what it was: a city, a port, scattered ruins from different time periods. The ocean floor doesn't preserve context the way land sites do, so we are assembling a puzzle with half the pieces missing. But the most undeniable discovery? Doggerland. This wasn't a mystery or a theory. This was an entire lost landscape between Britain and Europe that we've mapped, studied, and confirmed. 8,000 years ago, you could walk from London to Amsterdam without getting your feet wet. Doggerland was a vast, low-lying plain with rivers, forests, and human settlements. We know people lived there because we found their tools, their refuse, their footprints preserved in what's now underwater mud. Then, gradually, and then suddenly, the sea took it all. Rising sea levels from melting glaciers, tsunamis from underwater landslides. Within a few generations, an entire world disappeared beneath the waves. The people who lived there didn't have a choice. They fled inland, and their entire homeland became a memory, then a myth, then forgotten entirely, until we rediscovered it with sonar in the 21st century. Doggerland is proof of concept. It shows us that yes, entire inhabited landscapes can vanish underwater. Yes, rising seas can erase civilizations from the surface world. Yes, our ancestors lived in places that no longer exist above water. If it happened to Doggerland, it happened elsewhere. The question isn't whether coastal settlements were lost. We know they were. The question is how advanced they were before the ocean claimed them. Here's what's humbling. We've surveyed less than 20% of the ocean floor in any detail. Most of what we know about underwater topography comes from satellite measurements of the sea surface, which can infer the shape of the ocean floor below. It is like trying to understand what's in your basement by measuring tiny variations in your roof's height. It works, sort of, but you are going to miss details. The structures we found? They are the ones that happen to be in relatively shallow water, where people dive for recreation or fishing. They are the accidents, the lucky discoveries. Nobody systematically mapping the deep ocean looking for ancient ruins because it is expensive, time-consuming, and let's be honest, most archaeologists assume there's nothing down there worth finding. And maybe they are right. Maybe these formations really are just interesting geology. Maybe Bimini Road is beak rock, Yonaguni is erosion, and the Baltic Sea anomaly is glacial dumping. Maybe we are seeing patterns where none exist, because humans are wired to find meaning in randomness. But here's what archaeologists will admit after a few drinks. They are skeptical because they have to be. Science demands skepticism. But they'll also tell you that we've been wrong before. We didn't think complex civilizations existed in the Amazon until LiDAR revealed massive lost cities under the jungle canopy. We didn't think Göbekli Tepe could be 11,000 years old until the dating came back. We keep pushing back the timeline of human sophistication because we keep finding evidence that our ancestors were more capable than we gave them credit for. So when we look at these underwater formations and say probably natural, that probably contains a universe of uncertainty. It is not that scientists are hiding evidence or dismissing possibilities out of arrogance. It is that extraordinary claims require extraordinary evidence, and right now we are working with blurry sonar images and limited exploration of the least accessible environment on Earth. The ocean floor is a library where most of the books haven't been opened yet. We've glanced at a few covers, made educated guesses about what's inside, and called it a day. And that's not anyone's fault. It is just the reality of exploring an environment that actively fights back against exploration. What we found so far is tantalizing, suggestive, inconclusive. It is enough to make you wonder, but not quite enough to prove anything definitively. Which, honestly, is exactly what you'd expect if there were something down there waiting to be discovered. The first hints wouldn't be obvious. They'd be ambiguous, contested, easy to dismiss. They'd be exactly like what we are looking at now. And here's the thing that should make you sit up and pay attention. We already know how to do this. Not theoretically. Not in some far-off future. Right now. Today. Nuclear submarines have been keeping crews alive underwater for months at a time since the 1950s. These aren't small groups either. We are talking about 150 people living in a sealed tube at crushing depths, recycling their air, making their own water, functioning as a completely self-contained world. The USS Pennsylvania once stayed submerged for 140 days straight. That's nearly 5 months without surfacing, without resupply, without opening a single hatch to the outside world. Think about that. We've been running underwater cities on nuclear power for 70 years, and most of us never think about it. But submarines are military. They are designed for stealth and warfare, not long-term habitation. What about actual underwater living? What about staying down there not for a mission, but for a life? That exists too. Off the coast of Florida, there's a habitat called Aquarius Reef Base. It sits 60 feet underwater, and scientists live there for weeks at a time. Not visiting. Living. They sleep there, eat there, conduct research there. It is a saturation diving facility, which means once you are down, your body fully saturates with nitrogen at that pressure. You can stay down indefinitely. Coming up too fast would kill you, so you do not. You commit. You adapt. And here's where it gets interesting. NASA uses Aquarius to train astronauts. They call them NEMO missions, NASA Extreme Environment Mission Operations. Astronauts live underwater for weeks, simulating what it would be like to live on a space station or a Mars base. Because functionally, there's no difference. You are in a hostile environment. You cannot go outside without equipment. You depend entirely on life support systems. Your habitat is your world. If we can train for space by living underwater, that tells you something important. The technology for surviving in the deep ocean isn't some distant dream. It is proven. It is operational. We are already doing it. So what would you actually need? Let's break it down. First, air. You cannot bring enough oxygen tanks for years of life. You need to make it. Submarines do this through electrolysis, running electricity through water to split it into hydrogen and oxygen. The oxygen gets pumped into the air supply. The hydrogen either gets vented or used for fuel. It is elegant. It is efficient. And it works indefinitely as long as you have power and water. Speaking of water, you'd need to recycle every drop. Again, submarines already do this. They have distillation systems that purify seawater and reclaim water from everything. Yes, everything. Shower water, humidity pulled from the air, even urine gets processed and made drinkable again. The International Space Station does the same thing. On the ISS, astronauts joke that today's coffee is tomorrow's coffee. Same principle would apply in an underwater habitat. Nothing gets wasted. The system is closed. Food is trickier. You can store a lot, sure. But for true long-term survival, you'd need to grow your own. That means hydroponics or aquaponics. Plants growing in nutrient-rich water, maybe fish in the system too, creating a little ecosystem. The technology is mature. We've had successful closed-loop biosphere experiments. Biosphere 2, in Arizona, kept people alive for 2 years in a sealed environment back in the 1990s. It had problems, yes. Oxygen levels dropped, things got complicated, but it proved the concept. You can create a self-sustaining life support system if you design it carefully. Now, power. This is where the deep ocean actually offers an advantage. Geothermal vents. Down in the trenches, where tectonic plates meet and Earth's crust cracks open, superheated water comes pouring out. We are talking temperatures of 700 degrees Fahrenheit, sometimes higher. That's an enormous amount of energy. You could tap into that the same way we tap geothermal energy on land, run cold seawater through heat exchangers near the vents, drive turbines, generate electricity. It is renewable. It is constant. And it is right there. You wouldn't even need to be directly on a vent. Just close enough. Run pipes. Build infrastructure. If you are thinking long-term, if you are thinking civilization, then geothermal energy in the deep ocean is one of the best power sources on the planet. So we've got air, water, food, power. What about the habitat itself? Pressure is the obvious challenge. At the bottom of the Mariana Trench, you are looking at 8 tons per square inch. That'll crush almost anything. But here's the secret. You do not fight the pressure. You equalize it. Think of a submarine hull. It is not trying to keep normal atmospheric pressure inside while the ocean pushes from outside. Modern designs use pressure hulls, yes, but they are engineered to distribute stress. And if you are building a permanent habitat, you could design internal spaces where the pressure matches the outside. Saturation divers already do this. Their habitats pressurize to match their depth. Your body adapts. After a while, it is just normal. You'd still need areas with lower pressure for comfort, but those could be smaller chambers, easier to reinforce. The bulk of your living space could exist in equilibrium with the ocean. You are not in a battle with physics. You are working with it. Isolation is another challenge. Total darkness, no natural cycles of day or night, limited communication with the surface. Psychologically, that's hard. Submarine crews deal with it through strict routines, simulated day-night cycles with lighting, constant activity. Antarctic research stations have similar strategies for the endless winter night. It is not easy, but humans can adapt to almost anything if there's purpose and structure. And, honestly, the people who choose to live underwater wouldn't be random. They'd be committed. They'd be the kind of people who want isolation, who crave the unknown, who'd trade sunlight for discovery. The point is this: every single technological hurdle has already been solved in some form. We've got underwater habitats. We've got closed-loop life support. We've got renewable energy sources in the deep ocean. We've got materials that can withstand the pressure. The pieces exist. They are just scattered across different projects, different applications. If you needed to build an underwater civilization from scratch, you could. Not easily. Not quickly. But you could. Which brings us to the real question. If it is possible now, with modern technology, what could a civilization have managed if they'd had a compelling enough reason? If the surface world was ending and the ocean depths were the only refuge, they wouldn't need to invent anything impossible. They just need to put the pieces together. Just like we already have. They just need to put the pieces together. Just like we already have. And sometimes, we do not even need to piece things together. Sometimes, the earth itself hands us the evidence, entire chapters of human history written in mud, stone, and the memory of rising water. Because here's something most people do not realize. The world our ancestors knew looked completely different from ours. Not metaphorically different, literally different. The map was wrong. Or rather, we are looking at a different map entirely. 8,200 years ago, something happened off the coast of Norway that's almost hard to imagine. A section of the continental shelf, an area about the size of Iceland, just let go. The Storge Slide, they call it now. Think of it like this. Imagine a mountain of mud and rock sitting on an underwater slope, and one day, for reasons we are still debating, it just starts sliding. All of it. At once. The tsunamis that followed weren't like the ones we see today. We are talking about walls of water that crossed the entire North Atlantic. Coastal communities in Scotland, in Norway, in what's now submerged land between them, they would have had minutes maybe to understand what was happening. The archaeological record from that period just stops in certain places. Full stop. And we know why. But here's what makes this really significant. Those weren't empty coasts. They were home. You've probably never heard of Doggerland, and that's because it doesn't exist anymore. But 10,000 years ago, it was one of the best places to live in Europe. A massive plain connecting Britain to the continent, modern-day Netherlands, Germany, Denmark. It had rivers, hills, forests, animals, and people. Thousands of them. We know this because fishermen keep dredging up their tools. Harpoons, axes, even a fragment of a human skull once. The North Sea trawlers pull up bones of deer, mammoth teeth, worked flint. One fishing boat in 2017 brought up a 9,000-year-old antler point, still sharp, still clearly made by human hands, from what's now 60 feet underwater. Think about that for a second. These weren't people living on some remote island. They were living in the middle of what would become one of the world's busiest shipping lanes. They had homes there. They raised children there. They developed culture there. And then, slowly at first, and then faster, the sea came for them. Because that's the thing about sea level rise at the end of the Ice Age. It wasn't uniform. It wasn't a gentle, predictable process. Sometimes it happened in pulses. A glacial dam would break somewhere in North America, and within a generation, the coastline you grew up knowing would be a mile inland from where it used to be. Your childhood beach. None. Your father's fishing spot. Underwater. The sacred grove where your grandparents were buried. The waves are breaking over it now. There's this place in Wales, Borth, on the western coast, where at extremely low tides, you can walk out onto the beach and see them. Tree stumps. Hundreds of them. Rooted exactly where they grew 4,500 years ago, now preserved in peat and revealed by erosion. They call it the sunken forest, and it is not mythology, it is right there. You can touch them. These were oak and pine trees. Big ones. Which means this was dry land. Which means people would have known this forest. They would have hunted there, gathered there, maybe built homes nearby. And then the sea rose, and the forest drowned, and eventually even the memory of it faded until modern storms started uncovering it again. This is what I mean when I say the ocean swallowed the land. It is not poetic exaggeration, it is geological fact. And it happened fast enough that it shaped human history in ways we are only now beginning to understand. Because here's where it gets interesting. The people living on these disappearing coastlines. They would have been maritime experts by necessity. You do not watch your world slowly sink without learning everything possible about boats, navigation, and the sea. You do not survive that without becoming incredibly resourceful. They would have seen things most of us will never see, the slow transformation of their entire world. A grandfather telling stories about hunting in forests that his grandchildren can only reach by diving. Landmarks disappearing year by year. Old campsites becoming tide pool. And they would have known it wasn't stopping. That's the terrifying part. It wasn't like a flood that comes and goes. It was permanent. Relentless. Every year, a little more. Every generation, a little deeper. So what do? You adapt. You move. You innovate. You build better boats. You learn to read the water, the currents, the weather. You become a civilization defined by the water's edge, because the water's edge is literally chasing you. And some of you, maybe, you start thinking about other options. Because if the land keeps disappearing, and you've already mastered living with the sea, how big of a leap is it really to consider living in it? The evidence is there. scattered across submerged continental shelves all over the world. Footprints preserved in what used to be coastal mud, now hardened under the waves. Stone arrangements that look suspiciously deliberate. Remnants of fish traps and weirs built when the tide line was 100 feet lower than it is today. We are mapping these submerged landscapes now with increasingly sophisticated technology. Seismic surveys, underwater drones. And what we are finding is that human history didn't just happen on the land that's currently above water. It happened on all the land that was above water when humans were there to use it. Which means we are missing huge chunks of the story. Coastal peoples would have been some of the most advanced cultures. You have to be when you're working with tides, boats, and marine resources. But their settlements are now under 100 feet of water and 10,000 years of sediment. The Storge, Slide, Doggerland, the submerged forests. They are not just interesting footnotes. They are proof that the world we know is just the latest version of a world that's always been changing. That our ancestors lived through catastrophes we can barely imagine. And that they survived. They didn't just survive, they remembered. These aren't abstract archaeological sites. These are places where real people watched their world disappear and had to decide what to do about it. Some moved inland. Some moved along the coasts, following the rising water, staying in that narrow band between sea and sky. And some, if the theories hold any truth at all, might have made a different choice entirely. Because once you've watched the ocean swallow everything you've ever known, the ocean doesn't seem like such a strange place to go. Now, if you are going to hide an entire civilization at the bottom of the ocean, you've got to solve one pretty fundamental problem. How do you eat? Because down there, in the absolute darkness of the deep sea, the normal rules of life do not apply. No sunlight means no photosynthesis. No photosynthesis means no plants. No plants means no food chain. Or at least, that's what we thought until 1977. That year, a submersible called Alvin descended to a volcanic ridge near the Galapagos Islands. The scientists on board were expecting a barren seafloor, cold, dark, lifeless. What they found instead changed biology forever. Clustered around superheated water vents, in temperatures that would boil a lobster alive, they discovered life. Not just bacteria, but complex organisms. Giant tube worms as tall as a person. Eyeless shrimp swarming in the thousands. Clams the size of dinner plates. All of it thriving in conditions that should have been completely sterile. These organisms weren't eating anything. They were being fed by bacteria living inside them, bacteria that could do something we'd never seen before. They could take the chemicals spewing from the vents, hydrogen sulfide, the stuff that smells like rotten eggs, and turn it into energy. No sun required. It is called chemosynthesis, and it meant that life on Earth had found a completely different way to exist. Think about what that means for a second. Every living thing you've ever encountered, every plant, every animal, every person, ultimately depends on the sun for energy. It is the foundation of everything. But these deep-sea communities do not care about the sun. They've never seen it. They do not need it. They are running on Earth's internal heat, on the chemistry of the planet itself, in an ecosystem that could theoretically exist forever, completely independent of the surface. When this discovery was announced, it didn't just make headlines, it rewrote the textbooks. Suddenly, life seemed far more resilient than we'd imagined. If organisms could thrive in these conditions, then the requirements for life weren't as narrow as we thought. And here's where it gets really interesting. These vent ecosystems aren't small. Some cover areas the size of football fields, supporting thousands of organisms in intricate food webs. The tube worms can live for over 250 years. The communities are stable, ancient, self-sustaining. Now, Nobody's saying there's a civilization of intelligent tube worms down there. But what these ecosystems prove is that the deep ocean can support complex life without any connection to the surface world. It is a parallel biosphere running on entirely different chemistry. So if you are a group of humans forced underwater by some catastrophic reset, by rising seas or climate collapse, or whatever wiped the slate clean, you are not walking into a dead zone. You are walking into a place where life has already figured out how to exist without the sun. And if you are clever enough, if you are desperate enough, maybe you can learn to do the same. You need to harness that geothermal energy. Build your structures near the vents where heat and minerals flow continuously. Maybe cultivate those chemosynthetic bacteria. Learn to farm them the way we farm wheat. It sounds like science fiction, but the organisms down there are already doing it. They are already living off Earth's geology rather than its daylight. And there's another reason these ecosystems matter beyond just proving deep-sea survival is possible. They've changed how we think about life in the universe. Before 1977, if you asked a scientist where to look for alien life, they'd point to planets in the habitable zone, the narrow band around a star where water can be liquid and where sunlight can fuel photosynthesis. But after hydrothermal vents, that logic fell apart. Now, when we talk about potential life on Europa, Jupiter's ice-covered moon, or Enceladus, one of Saturn's moons, we're talking about oceans locked beneath miles of ice. No sunlight reaches those waters. They are pitch black, freezing, under unimaginable pressure. But if Earth's vents can support life in similar conditions, then maybe those distant oceans can too. Suddenly, the number of places in our solar system where life might exist went from 1 or 2 to a dozen or more. And it is all because of what we found in our own ocean. But here's the part that keeps some scientists, and plenty of theorists, up at night. If life can evolve intelligence on the surface, why couldn't it evolve intelligence in the deep? We know intelligence emerged in Earth's oceans before. Octopuses are stunningly smart, problem solvers, tool users, capable of sophisticated camouflage and planning. Dolphins use complex language and teach learned behaviors across generations. These are surface and shallow water creatures, sure, but they prove the ocean is perfectly capable of producing minds. Now, imagine an isolated biosphere around hydrothermal vents, running for millions of years without interruption. Evolution keeps happening. Organisms keep adapting. At some point, does something down there get clever? Does something develop a brain complex enough to wonder about its world the way we wonder about ours? It is a strange thought, but it is not impossible. And if humans arrived in that world, refugees from a dying surface, would they be the first intelligent life down there, or the second? These are the kinds of questions that didn't exist before 1977. Now they do. And the more we explore, the stranger the deep ocean becomes. Because every time we send a submersible down, we find something that shouldn't exist. Yeti crabs farming bacteria on their claws. Fish that glow with bioluminescence in patterns we are only beginning to understand. Microbes living inside volcanic rock, kilometers below the seafloor, in conditions we thought were too extreme for anything. Life keeps surprising us. The ocean keeps hiding new rules. And if there's one thing we've learned, it is that we've barely scratched the surface, or in this case, barely scratched the bottom. So when we wonder whether a lost civilization could have survived down there, we are not just guessing. We are standing on decades of evidence showing that the deep ocean is far more livable than it has any right to be. That life has already built entire worlds in the darkness. That energy, food, shelter, the basics of survival, are all available if you know where to look and how to adapt. The vents are still there, still pumping heat and chemicals into the abyss. The ecosystems are still thriving. And somewhere in all that darkness, there's still so much we haven't seen. The ecosystems are still thriving. And somewhere in all that darkness, there's still so much we haven't seen. But here's the thing about the ocean. It is not just dark. It is designed, almost perfectly, to keep secrets. Think about how we find things on land. We use our eyes. We use satellites. We can map entire continents from space with incredible detail. But water doesn't work like that. Light penetrates maybe 200 meters on a good day before it is completely absorbed. After that, you are working blind. So we use sonar instead. We send out sound waves and wait for them to bounce back, painting a picture of what's down there. And it works, to a point. But here's what most people do not realize. Sonar doesn't penetrate sediment very well. The ocean floor isn't just rock. It is covered in layers of mud, silt, and organic material that's been accumulating for thousands of years. Sometimes millions of years. If something's buried under even a few meters of that sediment, it is invisible to our detection methods. It is like trying to see through a thick blanket. The sound waves hit that soft layer and scatter, bounce off at weird angles, or just get absorbed. What's underneath? You'd never know unless you physically went down there and dug. And that brings us to the scale problem. The ocean covers 71% of Earth's surface. We've mapped about 20% of the ocean floor in high resolution, the kind of detail where you might notice something unusual. The rest, it is rough sketches at best. We know the general shape, the big features, but the fine details? They are missing. Imagine searching for something specific in an area the size of Asia, but you can only examine one small neighborhood at a time, and you are doing it in complete darkness with limited tools. That's essentially where we are. Now, add in the thermocline. This is one of those physical phenomena that sounds boring until you realize what it means for detection. The ocean isn't uniform. It is layered. There are distinct zones where temperature changes dramatically over a short depth. These layers act like mirrors for sound. A sonar pulse traveling through water hits a thermocline and part of it bounces back or bends away. It is acoustic refraction, the same principle that makes a straw look bent in a glass of water. What that means practically is there are entire regions of the ocean where sound just doesn't travel the way you'd expect. Dead zones, acoustically speaking. A submarine can hide in these layers, and surface ships have a hard time detecting it. It is not science fiction, it is standard naval strategy. And if a submarine can exploit this physics, well, so could anything else that understands how sound moves through water. You might remember the bloop. Back in 1997, underwater microphones detected an extremely loud, ultra-low frequency sound in the Pacific. It was picked up by sensors over 50 kilometers apart. Nobody knew what made it. The profile didn't match any known animal, any submarine, any geological process we were familiar with. For years, it was this tantalizing mystery. Was it biological? Something huge we hadn't discovered yet? The speculation got wild. Eventually, scientists determined it was most likely an ice quake, a massive ice shelf fracturing in Antarctica. The sound profile matched once they knew what to look for. Mystery solved, right? But here's what stayed with people about the bloop. The ocean surprised us. In 1907, with technology that was pretty good by that point, we were listening. We had the equipment, and something happened that we couldn't immediately explain. It took years to figure out. That's the thing about ocean acoustics. They are weird. Sound travels differently at different depths, different temperatures, different salinity levels. There are zones where sound gets trapped and travels for thousands of miles through what's called the SOFAR channel, sound fixing and ranging. Whales use it to communicate across entire ocean basins. But there are also zones where sound just dies. It dissipates, bends away, gets absorbed by the water's properties. If you wanted to hide something from acoustic detection, you'd put it in one of those zones. Not because you'd built some advanced sound dampening technology, just because the ocean's natural physics would do the work for you. And let's be honest about what we are actually monitoring. We've got hydrophone networks scattered around the ocean, mostly for tracking submarines and earthquakes. They pick up a lot: volcanic eruptions, whale songs, ship traffic, ice movements. But they are not everywhere. There are vast stretches of ocean where nothing's listening. Where something could happen, something could exist, and we'd have no idea. The statistical reality is humbling. Every year, researchers discover new seamounts, underwater mountains we didn't know existed. In 2023 alone, they found thousands of previously unmapped seamounts using improved satellite data. These aren't small features. We are talking mountains, and we are still finding them. If we are still discovering mountains, what else is down there that we've missed? Not just small things, substantial features of the ocean floor that haven't made it onto any map because nobody's looked closely enough yet. Now, I'm not saying there's definitely a hidden civilization exploiting these detection gaps. But I am saying the ocean is phenomenally good at hiding things, even from people who are actively looking. It is not just the darkness or the pressure. It is the fundamental physics of how energy moves through water, how sediment obscures, how layers deflect. If you were an advanced group trying to stay undetected, you wouldn't need to build some elaborate cloaking device. You just need to understand the environment. Pick the right depth, let the thermocline scatter sonar above you, settle into a basin where sound doesn't travel well, and let sediment accumulate over your structures over time. The ocean would do the rest. We like to think that in the 21st century, with all our technology, there are no blank spots left on the map. But the ocean is still a blank spot. Not because we are not trying, but because it is genuinely that difficult to see what's there. And maybe that's okay. Maybe some places are supposed to be hard to explore. But it does mean that when people ask, wouldn't we have found something by now if it was there? Well, no. Not necessarily. The ocean's too big, too layered, too good at keeping secrets. We've barely scratched the surface of what's down there, and the physics are working against us every step of the way. But here's the thing about those secrets: they do not always stay hidden forever. Sometimes they survive in the most unexpected way, through stories. Think about it. Before we had hard drives and cloud storage, before we even had writing, how did humans preserve important information? We told stories. And we told them over and over and over again. Around fires, during ceremonies, to our children before bed. That's how knowledge survived. And here's what's wild: it actually worked. We are not talking about vague fairy tales that got completely distorted. We are talking about oral histories that preserved accurate details for thousands of years. Aboriginal Australians have stories about when the sea levels were lower, when you could walk to places that are now islands. When geologists finally checked, they found those stories matched the actual timeline. Events from over 10,000 years ago, passed down through generations with remarkable accuracy. That's not just impressive. That's kind of mind-blowing. A people maintained precise geographical information across hundreds of generations, without writing any of it down. So when we find flood myths appearing in cultures all over the world, over 200 of them, from every inhabited continent, maybe we should pay attention. These aren't just stories people made up because they thought floods were scary. They are consistent. They are specific. And they are everywhere. The Epic of Gilgamesh, one of humanity's oldest written texts, has a detailed flood narrative. A man builds a boat, saves his family and animals. The waters rise and cover everything. Sound familiar? That's because you'll find the same basic story in ancient Greece, in Norse mythology, in Mesopotamia, in Polynesia, in indigenous cultures across the Americas. Different gods, different heroes, but the same core event: water rising, civilizations drowning, survivors fleeing. Now, you've got 3 ways to explain that. 1. It is pure coincidence. Hundreds of cultures independently invented the exact same catastrophic event in their mythologies, just because floods are universally scary. Possible, but it feels like a stretch. 2. It is a common human experience. These cultures all lived through localized flooding events, rivers overflowing, coastal storms, seasonal deluges, and they naturally wove those into their origin stories. More plausible, but it doesn't explain the scale these stories describe. We are not talking about a bad storm season. We are talking about world-ending floods. 3. They are all remembering the same thing. Somewhere in humanity's deep past, there was a catastrophic event, or multiple catastrophic events, that raised sea levels dramatically. And the people who lived through it told their children, who told their children, who told their children. The details shifted, got mythologized, picked up local flavor, but the core memory remained. The water rose, and everything changed. That's what mythology really is, when you think about it. It is proto-history. It is how people kept the past alive before they had the tools to record it with precision. And when you start treating myths as garbled records of real events, instead of just entertaining fiction, you open up some pretty fascinating doors. Indigenous knowledge has guided modern archaeologists to actual sites. Traditional stories about where people used to live, where they buried their dead, where important events happened. These have led researchers to genuine discovery. The stories weren't metaphors. They were maps. Take the Tamil legends of Kumari Kandam, a vast landmass that supposedly existed south of India before the oceans swallowed it. For a long time, scholars dismissed it as pure mythology. But then, we started finding evidence of submerged landmasses in that region, places where sea levels were much lower during the Ice Age. The specific details in the legend might be exaggerated, but the core idea, that there was once land where now there's only water, that part's true. Or look at the Japanese tales of Ryajajo, the underwater dragon palace. On the surface, it is a fantasy, a magical realm beneath the waves where time moves differently. But strip away the mythological dressing, and what do you have? A story about a place under the ocean, isolated from the surface world, where life operates by different rules. Is that really so different from what we are talking about? An advanced civilization adapting to deep-sea life, cut off from the rest of humanity, developing in its own unique way? The question isn't whether these myths are literally true. No one's arguing there's actually a dragon palace down there. The question is, what real experience inspired them? What were these cultures trying to remember? When independent cultures, separated by thousands of miles of ocean, tell fundamentally similar stories, you have to consider the possibility that they are all echoing the same distant event. Maybe not with perfect accuracy. Maybe not with all the details intact. But the echo's there. And that's the thing about cultural memory. It is resilient. Even when we lose the context, even when we forget why a story matters, we keep telling it. Because somewhere, deep in our collective consciousness, we know it is important. We know we are supposed to remember. Family stories work the same way, do not they? Every family's got that one story that gets told at reunions, that everyone's heard a dozen times. Maybe the details shift depending on who's telling it. Maybe it has gotten a little embellished over the years. But everyone agrees the core event happened, and everyone agrees it matters, even if they are not quite sure why anymore. Now, scale that up. Imagine a family story that gets passed down not for 3 or 4 generations, but for 300 or 400. What survives? The emotional truth. The big picture. The sense that something important happened, something we need to remember, even if the specifics have gotten fuzzy. That's what these flood myths might be. They are humanity's family stories, the ones we've been telling for so long that we've almost forgotten they are about real events. Almost. So here's where it gets interesting for our purposes. If oral tradition can preserve memories of sea level rise, of coastal lands disappearing, of people fleeing from drowning homelands, if those memories can survive for 0 years, then what else might be hiding in our myth? What other truths got wrapped up in legends about underwater kingdoms and lost civilizations? Maybe the stories about Atlantis, about sunken continents, about advanced peoples who disappeared beneath the waves, maybe those aren't pure invention either. Maybe they are the echo of something real, something that happened so long ago that the details got mythologized, but the memory never quite died. We cannot know for sure. That's the frustrating part. Cultural memory is powerful, but it is not perfect. It is like a photograph that's been photocopied dozens of times. You can still make out the basic image, but the clarity's gone. You are left guessing at details. But that's exactly why it is worth paying attention to. Because in a world where most of ancient history has been lost, where countless civilizations rose and fell, leaving almost no trace, these stories might be the only evidence we have left. They might be the only reason we are still asking these questions at all. The ocean swallowed the land. The water rose. The old world ended. People had to adapt or die. That's the story humanity kept telling itself, over and over, in 100 different languages, for thousands of years. Maybe we kept telling it because we were afraid it would happen again. Or maybe we kept telling it because, somewhere deep down, we knew we weren't supposed to forget what happened the last time. Because here's what humans actually do when everything goes wrong. We do not give up. We adapt. 50,000 years ago, our ancestors looked at the ocean, this vast, terrifying expanse of water that could swallow them whole, and decided to cross it anyway. They didn't have GPS. They didn't have weather satellites or Coast Guard rescue teams. They had canoes made from hollowed-out trees and stone tools that we'd consider laughably primitive today. And they made it. They reached Australia, crossing over 60 miles of open ocean, navigating currents and storms with nothing but ingenuity and courage. That's not luck. That's humans looking at an impossible problem and solving it because the alternative was staying where they were. That pattern repeats throughout history, and it is always most impressive when the stakes are highest. Take the Polynesians. Between 1500 BCE and 1000 CE, they colonized the Pacific Ocean, the largest feature on Earth. We are talking about finding tiny islands scattered across millions of square miles of water. No compasses. No maps in the way we think of them. Instead, they developed a navigation system so sophisticated that modern sailors are still in awe of it. They read the stars, yes, but they also read the waves. They could feel the patterns of ocean swells hitting their canoes and know an island was nearby, even when it was beyond the horizon. They watched birds. Certain species only flew a specific distance from land, so spotting them meant you were getting close. They used clouds, the color of the water, even the way the sky looked at sunset. And they memorized all of this, passing it down through generations with chants and stories, creating mental maps of an entire ocean. That's problem solving at a level that borders on superhuman. And they did it because they needed to. Because staying in one place wasn't an option, so they figured out how to turn the ocean from a barrier into a highway. Or think about Roman concrete. We've all seen ancient Roman structures, aqueducts, harbors, the Pantheon with its massive dome. A lot of them are still standing, 2,000 years later. And some of them are underwater, which is where it gets really interesting. Modern concrete crumbles in seawater. The salt corrodes it. It cracks. It fails. But Roman concrete? It actually gets stronger. Scientists only recently figured out why. The Romans mixed volcanic ash into their concrete, and when seawater seeps in, it triggers a chemical reaction that creates new minerals, filling in cracks and reinforcing the structure over time. The Romans didn't understand the chemistry. They didn't have laboratories or electron microscopes. They just experimented, noticed what worked, and perfected it through trial and error. They solved a problem we forgot how to solve for 2 millennia. We had to reverse engineer their ancient recipe because we'd lost the knowledge. That's the thing about human ingenuity. It doesn't require modern technology. It requires necessity and creativity. Look at the Inuit in the Arctic. They've lived in one of the most hostile environments on Earth for thousands of years, a place where temperatures drop to 50 below zero, where the sun disappears for months, where one mistake means death. And they thrive. They built homes from snow that stayed warm inside. They invented kayaks and toggle-headed harpoons. They developed an entire culture around cooperation and knowledge sharing because individual survival wasn't possible. You needed the community. They created detailed mental maps of a landscape that looks identical in every direction, navigating by the shapes of snowdrifts and the texture of ice. They proved that humans do not just survive harsh conditions. We master them. But let's talk about something more recent. The Manhattan Project. In 1942, scientists didn't know if splitting atoms for a controlled chain reaction was even possible. The physics was theoretical. The engineering was unprecedented. And they had maybe 3 years to figure it out, build it and test it, all while keeping it secret from the rest of the world. Most experts at the time thought it couldn't be done. Too complex. Too many unknowns. Too many things that could go wrong. They did it anyway. By 1945, they'd built functioning atomic bombs and detonated them. You can debate the ethics all you want, and people do, but from a purely technical standpoint, it demonstrated something crucial about humans. When we are motivated enough, we can achieve things that seem theoretically impossible. We compressed decades of research into a few years. We invented new fields of science and engineering on the fly. We coordinated thousands of people across multiple secret sites, solving problems nobody had ever encountered before. And we did it because we had to. That's the pattern. That's what keeps showing up throughout history. Humans are at their most innovative when survival is on the line. So now, imagine a reset scenario. Imagine civilization collapsing, climate catastrophe, natural disaster, whatever the cause. Imagine the survivors realizing the surface is no longer viable. The question isn't whether humans could adapt. The question is how. Because if you are facing extinction, you do not politely accept it. You look for solutions. And if the only viable solution is going underwater, you figure out how to make that work. You do not have a choice. You'd start with what you know. Submarines prove we can maintain sealed environments underwater for months. Saturation diving shows humans can live at depth if the pressure is equalized properly. Hydrothermal vents provide energy and support ecosystems that do not need sunlight at all. You'd experiment. You'd fail. People would die. But some attempts would work, and those survivors would build on that knowledge. Within a generation or two, you'd have communities adapted to deep ocean living, not because they wanted to, but because they had no alternative. And here's the thing, we know humans can live in extreme isolation because we've tested it. NASA's NEMO mission sent scientists to the Aquarius Reef Base, an underwater habitat off the coast of Florida, where researchers live submerged for weeks at a time. They are essentially living in a metal tube on the ocean floor, studying how humans handle isolation, confinement, and complete dependence on technology for survival. It is preparation for Mars missions, but the parallels are obvious. If we can learn to live on the ocean floor, we can learn to live anywhere. And if our ancestors faced extinction, they wouldn't have been thinking about Mars. They'd have been thinking about anywhere that kept them alive. The technology would evolve. What started as desperate survival measures would become refined over generations. You develop better materials, more efficient life support systems, ways to farm food in the darkness. You'd learn to navigate and communicate in the deep. You'd build structures that could withstand the pressure. And eventually, it wouldn't feel like hiding. It would just be home. That's what humans do. We adapt. We overcome. We turn the impossible into the routine, and then we forget we ever thought it was impossible in the first place. So when people say a civilization couldn't possibly survive underwater after a catastrophic reset, they are forgetting what humans are capable of when everything depends on. We've crossed oceans in canoes. We've built empires in the Arctic. We've split atoms because we had to. Surviving in the deep ocean? That's not impossible. That's just the next problem we'd solve. Because you know what's fascinating about all this? The ocean isn't the only thing that might be hiding something from us. Time itself might be doing the same. Think about how history works. We assume it is this straight line. We started in caves, invented agriculture, built cities, and here we are with smartphones and space telescopes. Progress, right? One direction. Always forward. But that's how civilizations actually behave. The Romans had concrete that lasted millennia. We lost that formula. The Greeks calculated the Earth's circumference with stunning accuracy. That knowledge vanished for over 1,000 years. The Library of Alexandria burned, and with it, who knows how many discoveries we had to reinvent from scratch. We forget. We've always forgotten. And here's the uncomfortable part. We might be really, really good at it. There's this idea that shows up everywhere once you start looking for it. Eastern philosophy talks about yugas, these great cycles where civilizations rise and fall like seasons. The Greeks had their ages of gold, silver, bronze, and iron. Oswald Spengler wrote about civilizations as organisms that are born, mature, and inevitably die. Arnold Toynbee documented 23 major civilizations and found they all followed similar patterns of growth and collapse. It is not just mysticism or pessimism. It is pattern recognition. Every great civilization tells itself the same story before it falls. We are different. We are special. We've figured it out. Neo. The Romans thought their empire would last forever. The British believed the sun would never set on theirs. Each one was convinced they'd broken the cycle. They hadn't. And there's usually a moment, you can spot it in the histories, where hubris takes over. Where civilization stops learning from the past because it believes it has transcended it. That's when the cracks start showing. Now, you might be thinking, okay, but we have books now. The internet. We are not going to forget. Are we sure about that? How much of your own great-grandparents' knowledge do you actually possess? Can you do what they could do? Build what they could build. Navigate by stars, preserve food without refrigeration, fix complex machinery without watching a YouTube tutorial? We've traded depth for breadth. We know on-time things exist, but we've outsourced the knowing how to specialists and search engines. And that's fine, until it isn't. Imagine if a solar flare took out the power grid tomorrow. How much of our digitized knowledge would we still have access to? How many of us could actually rebuild from scratch? This isn't meant to sound apocalyptic. It is just honest. We build monuments to remember. The pyramids, Stonehenge, Mount Rushmore, they are not just art. They are messages to the future, desperate attempts to say we were here, we mattered, do not forget what we learned. But erosion doesn't care about our intentions. Neither does time. The really wild thought experiment is this: what if we've already forgotten something crucial? Not just technical knowledge, but something bigger. What if there was a previous iteration of advanced civilization on Earth, and they left warnings, or wisdom, or even just evidence, and we've been walking past it for generations without recognizing what we are looking at? Because here's the thing about karma, and I do not mean the pop culture version, where bad people get instant comeuppance. I mean the original concept, which is about causality rippling through time. Every action has consequences. Not just immediate ones, long ones. When we dump chemicals in the ocean, we do not see the effects for decades. When we build a nuclear reactor, we are creating waste that'll be dangerous for thousands of years. When we change the climate, we are altering conditions for civilizations that do not even exist yet. Our choices echo forward. And if that's true, then the inverse is also true. The choices of past civilizations echo backward to us. Their environmental impacts, their genetic legacies, their surviving technologies. We are living in the shadow of decisions made by people whose names we'll never know. What if the ocean isn't just hiding a civilization? What if it is hiding a warning? There's something deeply karmic about the idea that we've spent the last century exploring space while ignoring the ocean at our feet. We've been looking up when maybe we should have been looking down. And now, as we face our own environmental tipping points, we are finally turning our attention to the deep. Timing's funny like that. If we are not the first advanced civilization Earth has produced, and I am not saying we aren't, but if, then what happened to them matters intensely. Because whatever pitfall they hit, we are probably heading toward the same one. Did they outgrow their resources? Poison their environment? Destroy themselves in conflict? Or did they simply get comfortable and stop adapting? And if some of them survived by adapting to the one place a reset couldn't reach, if they went deep, where pressure protects and darkness conceals, then they'd know something we do not. They'd know how to survive the cycle. Maybe that's the real treasure at the bottom of the ocean. Not gold or technology or proof of ancient glory, but wisdom. The hard-earned knowledge that comes from watching your entire world transform and figuring out how to persist anyway. We like to think we are special. That, this time, it is different. That we've learned from history and will not repeat it. But the ocean keeps its secrets. And time? Time keeps score. The question isn't whether civilizations fall. They do. The question is whether we are clever enough to recognize the pattern while we are still part of it, and adaptable enough to do something about it. Because here's the hopeful version of this thought: cycles aren't prison sentences. They are rhythms. And if you understand the rhythm, you can learn to dance with it instead of being swept away by it. Maybe that's what those monuments are really about. Not ego. Not immortality. They are sheet music. Instructions for the next dancers. And if there's someone down there in the deep who learned the steps long before we did, that's not a threat. That's a teacher we didn't know we had. So what would it actually mean, really mean, if we found them? Let's start with the obvious. The first few hours would be chaos. Every government with a submarine would scramble to claim jurisdiction. The UN would convene emergency sessions. Scientists would be booking flights before their coffee got cold. Social media would explode with theories, memes, and probably 100 new conspiracy channels launched before lunch. But that's just the noise. The real shift would be quieter, deeper, and far more profound. Within weeks, every history textbook on Earth would be obsolete. Not wrong exactly, just incomplete. We'd have to add an asterisk to everything we thought we knew about human civilization. The first cities were built in Mesopotamia, unless you count whatever's down there. Humans evolved from hunter-gatherers to farmers, or some of them went in a completely different direction we never imagined. Archaeology as a field would split in two. There'd be the history we know, and then there'd be them. A parallel track we'd have to map backward through time, trying to figure out where our stories diverged. And here's the thing, they might have answers we've been looking for. Imagine if they preserved records. Not like our libraries, probably nothing we'd recognize as writing at first, but information nonetheless. Maps of coastlines before the floods. Techniques for surviving what we can barely comprehend. Maybe even warnings etched into something that lasts. This is what happened to us. Do not let it happen to you. Or maybe they'd have technology. Nothing flashy, forget flying saucers. But what if they figured out something we haven't? A way to purify water that doesn't need electricity. Materials that withstand pressure we cannot replicate. Energy systems built around geothermal vents that could revolutionize how we think about sustainability. The knowledge wouldn't just be academic. It'd be practical. Applicable. It'd be like finding your great-great-grandfather's journal and realizing he solved a problem you've been struggling with your entire adult life. But contact itself. That's where it gets strange. We are assuming they'd want to talk to us. We are assuming they even ecody. Think about it. If they've been down there for 10,000 years, they didn't develop language the way we did. They didn't evolve communication around firelight stories or market negotiations. They adapted to near total darkness, to environments where sound travels differently, where sight might be useless. They might communicate through bioluminescence patterns, through chemical signals we cannot detect, through vibrations in water that our instruments would register as noise. We could be standing right next to them, metaphorically speaking, and not even realize we are having a conversation. And time, their sense of time would be completely alien. We measure our days by the sun. They wouldn't have that. No seasons, no harvest cycles, no reason to think in terms of years the way we do. If they are living near hydrothermal vents that have been stable for millennia, what's a decade to them? What's a century? They might perceive us the way we perceive mayflies. Here for a blink, then gone. Or maybe they'd see things the opposite way. To them, we'd be the ones moving impossibly fast, burning through resources, building and destroying in the span of what they'd consider a moment. They might pity us, or fear us, or both. Which brings us to the ethical minefield. What gives us the right to disturb them? If they chose isolation, actively chose it after whatever catastrophe drove them down there, then showing up with submarines and cameras is the equivalent of knocking down someone's door because you are curious about their lifestyle choices. They didn't ask to be discovered. They are not some lost tribe waiting for rescue. If they survived this long, they do not need us. But we'd want access anyway. Of course we would. The scientific value alone would be irresistible. And let's be honest, governments would see strategic value. Resources. Technology. Real estate on the ocean floor suddenly looks very different if someone's already living there successfully. We'd have to decide whether first contact protocols apply to other humans. Whether they are even still human in a way we'd recognize after 10,000 years of separate evolution. Whether the word civilization means they get rights, or just makes them more interesting to study. It is colonialism with extra steps, and we'd have to confront that. But here's what might be the biggest shift of all. It is not about them. It is about us. Right now, we see ourselves as the success story. The ones who made it. We climbed down from the trees, mastered fire, built cities, split the atom, went to the moon. We are the proof that intelligence and civilization can work. But if they are down there, then we are not special. We are just the ones who stayed on the surface. And if they survived a reset we have no memory of, then our civilizational amnesia isn't just an interesting mystery, it is a warning. It means it has happened before. It could happen again. And we are not paying attention to the signs. Suddenly, every climate report reads differently. Every political conflict over resources feels more urgent. Every long-term problem we've been kicking down the road for our grandchildren to solve becomes something we need to face now, because the Earth has already shown it doesn't wait for us to get our act together. Finding them would be like finding out you are not an only child after 40 years of thinking you were. Everything about your identity shifts. The stories your family told about you being special? They are not exactly lies, but they are not the whole truth either. You are not the sole heir. You are not the one and only. You are one of several, and someone else might have figured things out better than you did. That's humbling. That's uncomfortable. But maybe, just maybe, it is exactly what we need. Because the question isn't really what would finding them mean. The question is, what would we do with that knowledge? Would we learn from them or try to dominate them? Would we protect their isolation or exploit their resources? Would we see them as teachers or threats? The answer to that would tell us more about ourselves than it would about them. And that might be the whole point of the mystery, not to find them, but to ask ourselves who we'd be if we did. So here's where it gets exciting. The future isn't just speculation. It is already being built. Right now, there's a fleet of autonomous underwater vehicles being designed that'll change everything. These aren't the clunky, tethered robots we've relied on for decades. We are talking about AI-powered machines that can dive to crushing depths, make their own decisions about where to explore, and map the ocean floor faster than we've ever dreamed possible. Some of them can stay down there for months, recharging at underwater docking stations, sending back data continuously. It is like we are finally giving the ocean the attention we've been giving Mars. And there's a reason for the urgency. The Ocean Census Project launched recently with an ambitious goal: discover 100 new species by 2030. That's not a typo. 100,000 species we do not know about yet, living in our own oceans. The scientists behind it aren't being optimistic. They are being realistic. Every deep dive brings back creatures that rewrite what we thought was possible for life on this planet. We are not running out of discoveries down there. We are just getting started. Here's something ironic. Climate change, for all its devastation, is actually helping us see what's been hidden. As glaciers melt and sea ice retreats, we are finding archaeological sites that have been frozen for thousands of years. Ancient shorelines are emerging. Submerged forests are becoming visible. It is a bittersweet trade-off, but it means we are getting glimpses into coastal civilizations that were swallowed by rising seas during past climate shifts. We are literally watching history resurface. And it is not just governments funding this anymore. Private companies are jumping in. You've probably heard about billionaires racing to space, but there's a quieter race happening toward the ocean floor. Companies are developing deep-sea mining technology, underwater tourism submarines, and permanent research installations. Some of them are motivated by profit, sure. There are rare minerals and resources down there. But profit drives innovation, and that innovation means better tools for everyone, including scientists who just want to understand what's down there. The next generation of underwater habitats is already in development. We are talking about structures that could support researchers for months at a time, living and working at depths we've barely visited. Think of it as the International Space Station, but anchored to the seafloor. These aren't science fiction concepts. Prototypes exist. The technology for long-term underwater living has been proven. It is just a matter of scaling it up and making it sustainable. And when that happens, we will not be visiting the deep ocean anymore. We'll be living there. There's something else worth mentioning. We've learned more about the ocean floor in the past 10 years than in all of human history combined. That's not hyperbole. It is what happens when satellite technology, AI, and international collaboration converge. Projects that would have taken decades with old methods now take months. We are finally mapping the seafloor and the kind of detail that might actually reveal something we've been missing. Every year, the resolution gets sharper. Every year, we see a little more clearly. So why are people calling the 2030s and 2040s the potential golden age of ocean discovery? Because for the first time, our technology is catching up to our ambitions. We've wanted to explore the deep ocean thoroughly since we first realized it existed. But we've been trying to do it with equipment that was barely adequate. That's changing. The sensors are better. The vehicles are smarter. The funding is increasing. And perhaps most importantly, we are starting to treat ocean exploration with the same seriousness we've reserved for space. Think about what that means. Within your lifetime, we might map every square mile of the ocean floor in detail. We might catalog most of the species living down there. We might find structures, artifacts, or formations that completely change how we understand human history. Or we might not, but we'll finally know. We'll have actually looked. And that's really what this is about. Not finding a specific answer, but removing the excuse of ignorance. For all of human history, we've been able to say, we haven't looked, so we do not know. That era is ending. The ocean is about to give up its secrets, not because it wants to, but because we are finally capable of taking them. The tools exist. The motivation exists. The technology is advancing exponentially. What happens next isn't a mystery, it is an inevitability. We are going down there. We are going to look. And whatever we find, ancient ruins, thriving ecosystems, geological wonders, or even nothing at all, it'll reshape how we see our planet. Because here's the thing about exploration, it is never really about what you are looking for. It's about what you are willing to find. And right now, humanity is more willing than we've ever been to discover that everything we thought we knew was just the beginning. The deep ocean isn't going to stay mysterious much longer. The question isn't whether we'll explore it thoroughly. The question is what we'll do with what we find when we finally get there. And that's really what drives us forward, isn't it? Not just the technology or the funding or the missions, but that fundamental human ache to know we are not alone. Whether we are scanning the stars for radio signals or sending robots into trenches 7 miles deep, we are asking the same question our ancestors asked when they stared at the horizon. What else is out there? There's something almost childlike about it. That same impulse that made you peek under the bed or open the closet door even when you were a little scared of what might be inside. We need to know. It is hardwired into us. And the deep ocean hits that nerve in a way few things can, because unlike Mars or distant galaxies, it is Hera. It is part of our home. We live on the same planet as these mysteries. They are not light years away, they are just straight down. But here's the thing that doesn't get talked about enough. Mystery serves a purpose. It is not just an absence of knowledge that needs filling. Mystery keeps us humble. Every time we think we've got it all figured out, the universe reminds us how little we actually understand. The ocean does this constantly. Scientists discover new species in places we swore couldn't support life. Sailors report phenomena that defy easy explanation. Sonar picks up sounds we cannot identify. And instead of being frustrated by what we do not know, maybe we should appreciate what that ignorance gives us: perspective. There's a comfort in uncertainty. Not everything needs to be solved to be meaningful. Think about your favorite song. If someone explained every technical detail, the exact frequencies, the chord progressions, the compression ratios, would that make you love it more? Or is part of its magic that it just works on you in ways you cannot fully articulate? The ocean's mysteries are like that. They touch something deeper than facts and figures. They remind us that the world is bigger than our understanding of it. And that's not a failure. That's a gift. You know what connects us to every generation that came before us? This exact feeling. The sailors who crossed the Mediterranean 3,000 years ago looked at the same water and wondered what lived beneath. Indigenous peoples told stories about the ocean's spirits and hidden kingdoms. Victorian naturalists dragged nets through the deep and gasped at creatures they couldn't believe were real. Your great-great-great-grandparents looked at the sea and felt that pull. And your great-great-great-children will too. We are part of an unbroken chain of curious humans who refuse to let mystery go unanswered. That's why these questions about lost civilizations and sunken worlds resonate so deeply. It is not really about whether there's a city down there or a group of survivors living in artificial habitats near a thermal vent. I mean, wouldn't it be incredible if there were? Absolutely. But the real power of the question is what it makes us consider about ourselves. If a civilization could survive a reset, what does that say about human resilience? If they adapted to the most hostile environment on Earth, what are we capable of if we are truly pushed? If they are down there choosing isolation, what does that tell us about the price of survival? We are not just wondering about them. We are wondering about us. And the beauty is that the universe still has secrets. After everything we've learned, after sending people to the moon, splitting the atom, mapping the human genome, capturing images of black holes, there are still places we haven't been. Still creatures we've never seen. Still questions we cannot answer. That should feel incredible, not disappointing. It means there's still wonder left in the world. Still discoveries waiting for the next generation of explorers. The journey matters more than the destination anyway. Every expedition into the deep teaches us something we didn't know. About geology, about biology, about engineering, about what humans can endure. James Cameron's dive to the Challenger Deep didn't find a lost civilization, but it proved a human could get there and back. That matters. The discovery of hydrothermal vents didn't reveal an underwater society, but it completely rewrote what we thought we knew about where life can exist. That matters too. Each answer leads to new questions. That's not a bug, that's the whole point. The goal isn't to close the book on mystery. It is to keep turning pages. So will we ever find evidence of a civilization that survived a reset in the deep ocean? Maybe. Maybe not. The honest answer is we do not know. But here's what we do know. We'll keep looking. Because that's what we do. Humans explore. We push boundaries. We ask questions that might not have answers. We shine lights into dark places. We climb mountains and dive trenches and build telescopes and submarines, all because somewhere deep in our DNA is a voice that whispers, "What if?" Hunt as long as that voice exists, as long as there's a kid looking at the ocean and wondering what's below, as long as there's a scientist designing the next generation of underwater drones, as long as there's someone like you who clicked on a video about impossible mysteries, we'll never stop looking. The deep ocean will keep its secrets as long as it wants to. But we'll be there, persistent and patient and endlessly curious, waiting for the moment it decides to reveal just one more. Because in the end, these mysteries aren't about finding answers. They are about remembering that we are still capable of wonder. that the world is still vast and strange and full of possibility. That no matter how much we think we know, there's always something deeper, something older, something waiting just beyond the edge of our understanding. And maybe that's exactly how it should be. The ocean's been here for 4 billion years. It has watched continents drift and species rise and fall. It has swallowed coastlines and birthed life itself. It is not in a hurry to give up its mysteries. But we've got time. We are patient. We are clever. We are endlessly, helplessly, beautifully curious. So whether there's a lost civilization down there or not, whether the younger Dryas refugees found a way to survive in the abyss or not, whether ancient myths preserve memories of real events or not, we'll keep exploring. Keep questioning. Keep wondering. Because that's the real gift of mystery. Not the answer. The search itself. And the search is far from over.